Hey folks, we need to talk about AI. uh, I've been a long time skeptic uh, for environmental reasons mostly, but I've been a long time skeptic for AI. And things have changed in the last couple of months, and things have changed so much that I am making this video even as a skeptic because I think our profession as software engineers is at an inflection point. Things are about to start changing really rapidly. Um, but maybe let me give you a bit of context here. Why am I an AI skeptic? Doesn't really matter. Why have I become? Why am I starting to take a look at these tools? Because people I look up to and loud voices in the tech profession, people like Kent Beck, people like Simon Wardley, people like Dave Farley from Modern Software Engineering, they are starting to talk about these things in a it's ready for production use kind of way. So that was for me the trigger that I'm missing the train here. So that's why I started digging into things, and they are right. Things are changing. But before we go over the what is changing, I wanted to give a quick video for people that have also, like me, had their heads in the sand and like ignoring everything and like, okay, ChatGPT, browser, chatting, cool. Or it's like a fun plaything, but nothing really serious. I'm telling you right now, for developers, it's becoming something serious. It has its upsides and its downsides, but I have become more bullish. So what is the purpose of today's video? Just showcasing what it means to program with AI. So AI-assisted coding, not vibe coding, not like just prompting your way to an app. I want to show you what potentially the coming year, 2 years of programming will look like. So it's showing you how I work as a developer now and with these tools. And to appease my inner skeptic, I designed an experiment, and I'm going to be doing that experiment twice. I'm going to run it once without AI assisting tools manually, like I would do a year ago or even 6 months ago. And then I'm going to do the exact same experiment, but this time using AI assisted coding tools. And we're going to talk about what it means for code quality, for speed of delivering your work, and how fun it is, stuff like that. So those are topics I want to touch. So let me first quickly show you the experiment, then do it manually, and then the moment you've been waiting for, we're gonna program with large language models. First things first, what's the experiment? The experiment is a refactoring session. So that's when you have a user story and you have to implement some new behavior, and you open up the code and, oh no, the code is a mess and I have to change it for this story. What the software engineer typically does at that time is clean it up a bit so the new functionality can slot in better, easier, in a better design, and then implement that new feature. There's programming exercises galore for these kinds of challenges. I took a famous one about parrots. If you know Monty Python, it'll give you a good laugh. But it's a refactoring kata where you have to implement a new type of parrot in a code base about parrots. Let's not get into the details, but that's the big picture. I took that programming exercise and I embedded it in a big reference code base. So this is the ASP.NET Core reference application. It's called eShop on Web. Doesn't really matter, not important, but I ported the code in there. I did one more thing. I got rid of every reference to a parrot. I don't want to give these LLMs unfair advantage because the parrot kata has been heavily written about on the internet. So I obscured this exercise, and I'm a dog person, so we will be talking about dogs and barking, stuff like that. So that's the setup of this experiment, and now we're gonna implement a new breed of dog. We're gonna implement a Pekingese. Not my favorite kind of dog, but it's the only one I could think of. So we're gonna do that manually first, and then you have a feel and a look of how that looks like, and then we're gonna do the same thing with AI-assisted coding tools, and then we'll compare like how those two things behave. So let's just dive right into it. All right, so it's time for the baseline. As you can see, I added a timer at the bottom right so we can somewhat time our work. And this will be without AI assistance. This will be just refactoring in my IDE, which is Rider. I have my tests set up. In the bottom left, you see my test feedback. So if I run those tests, it takes a couple of seconds and it's green, so the tests are passing. So we would like to implement a Pekingese dog breed with some kind of behavior specific to it being hungry or not. But before we do that, I like to perform Kent Beck's make the change easy, then make the easy change. So before we start digging into this messy code, let's refactor to a cleaner solution. And the refactoring I'm going to take is called replace conditional with polymorphism, which kind of implements a type hierarchy, and all those switch statements will disappear and it'll be just delegation to the correct subtypes. So I'm going to introduce Labrador subtypes, stuff like that, each with their own behavior. Why am I choosing this refactoring? Because I think this might be the sweet spot for these AI assisted tools. These bigger refactorings like this are not supported by modern IDEs because they're like too fluffy. But I think maybe like these recipes that are like somewhat, they make sense. I as a human can interpret these recipes and perform the steps one by one and end up with a satisfactory result. So I'm hoping that these AI assisted tools are like bridging the gap between what an IDE can do today and what I have to do. Because if we're going to look at this DIY baseline, you'll see me do 20, 30, 50 different refactorings, and maybe these tools will do it in bigger steps. That's at least my hypothesis, which we're going to test. And I've been yapping about for 2 minutes, so I'm going to reset my clock. 2 minutes is significant for this kata, so yeah, let's go again and let's start the exercise. So first things first, let's refactor this thing so it uses polymorphism. First things first, let's see where this thing is used. It's used in all the unit tests, but also in a couple of other places in this code. I had hooked in this dog type into the code base to be more like realistic. So this code is being used in a couple of places. And if we want to refactor to polymorphism, one of the steps is use a factory method. So let's introduce a factory method. And that is an automated refactoring that is supported. There's the replace constructor with factory method. And I'm going to call the factory method create, and I want it inside the dog class. Sure. So Rider just created the factory method. It rewired all the constructor calls to this factory method. And now my constructor is private. So we have one place in the entire code base that initializes the new dogs. Now we can do switch on type. And we'll create an arm for every subtype of dog. And let's just make a new dog in each and every arm. So this is not doing much interesting, but at least my code compiles and now the door is open for subtypes. So I'm going to run my tests quickly. They are green. Let's proceed. Let's introduce subtypes. So I'm going to introduce a pointer type. It's a type of dog. It should call the base constructor, which has to become protected. Sure, sure, sure. Now we have pointers. Let's introduce retrievers as well. Also calling the base class constructor and not throwing exceptions. And finally, let's introduce Labrador. There we go. Base initializer, no exceptions. So we have our subtypes. We're good to go. Everything should still be green. Now let's take a look at pushing down several methods. So I want to push this behavior down and I want to get rid of this type switch. So let's do this in a couple of steps. Let's refactor and push this member down to all subtypes, and let's leave an abstract method in the base class so users of the dog type know that they can request running speed of a dog. It has to make several things protected, which is expected, so let's go ahead. And now let's take a look at the push down methods. So for Labrador, for example, you see that it pushed down the entire method, but we know that it's a Labrador, so this is the only part that matters. Let's get rid of this type switch and just keep the Labrador's running speed. Let's do the same for Retriever. And Pointer. I'm doing two things at the same time. I'm not good at multitasking, so forgive me. That's a typo, there we go. And let's do the same for Pointer, which is just a base running speed. There we go, this can go. So we dispatched everything for the running speed. Let's run our tests to make sure. Yeah, everything is green, we can continue. Let's do the same with Bark. We're pushing it down, keeping an abstract method, and then we can get rid of the dead code. This is a Labrador. This is what the Labrador code should do. This is that code. And for Retriever, same thing. It should just say WAF. Don't need this switch anymore. And for Pointer, it should say woof. And don't need this anymore. Let's run the tests. And let's take a look at our resulting code. We have our factory method, we have some abstract methods. So this is already good, but not great. If you take a look at what's over, oh, there's that code. So let's get rid of unused type fields. Let's get rid of it in the constructor. So the only place where the dog enum is being used should be in this factory method. And we see that it's also being passed down in the individual constructors. So we can get rid of that as well. Don't need it, don't need it, don't need it. Okay, so we got rid of the enumeration. I don't like where we ended up. It's not done for me. I see like properties, and if you take a look at where these properties are being used, it's being used in only one subtype. So I want to push these things down as well. Potty trained should go to a Labrador. So let's push that property down. Exact same refactoring. And I want to push it to the Labrador. And it's saying, oh, I can't do that because you're setting it in a constructor. Let's set it in the Labrador constructor instead. So is potty trained. There we go. We can make this private read-only. And we can remove it from the original constructor and all other constructors, but let's do a bigger step and let's do all the other properties as well. So number of bones, where is this thing used? In Retriever. So let's push this down to Retriever. There we go. And it breaks again, but we know we have to fix this in the Retriever constructor. There we go. We can get rid of it in the base constructor. And liters of water, let's go. We're taking a big step. Oh, it's being used in two call sites, which is running speed of Labrador and Bark, also of Labrador. So this can go to Labrador. Let's push it down to the lab. Yep. And we know that the refactoring fails already, but if we go to the lab, we can add the liters of water setter right there. So it's initialized. Okay, now we can get rid of a lot more dead code. So constructor arguments can go, constructors can go. That's already fine. Let's go to the lab constructor. Stuff can go, calls to the base, initializer can go. Same for Retriever, lots of things can go. So I'm using automated refactorings. This is not AI, this is me just hitting Alt Enter a lot. There we go. I think it's time to run our tests. Compile error, that's not something I was expecting. Pointer. Oh yeah, I did that one differently. I took like a big delete. So If I used my refactoring shortcuts, it would not have broken the code. But yeah, everything is green. So let's take a look at the end result. We have our enumeration. We have a factory method. And yeah, it starts to look good. Let's make these things private read-only. While we're at it, I'm a stickler for details like this, so forgive me. Yeah, looks good. Now if you take a look at what's in the base type, you see that it's a get running speed abstract method. That's perfectly fine. This thing, get base speed, is only used in one call site, which is lab. So I'm gonna push that down as well to the lab class. That can go to the Labrador. We don't need any abstract base methods. We can do the same for bone factor. Bone factor is being used in retriever, so we can push that down to retriever. It's gone. Base running speed can stay, and bark is abstract. So I think we might be done with the refactoring 9 minutes in. Let's run our tests to make sure, and then we can implement the new Pekingese dog type. We are green, we're good to go. Let's write our tests for the Pekingese. I think I have them somewhere. I'm not gonna bore you while I write our unit tests. So let's implement our Pekingese step by step. And let's write a new unit test that says a Pekingese should be barking hungry when it has not enough food. And I arbitrarily pick like 100 food is enough for this little dog. So I write this test, a program by wishful thinking, and it's not compiling, so let's make it compile first by adding Pekingese to the enum, and then my constructor call, which I would like to be a factory method call instead. There we go. It's failing because I introduced an extra argument, and I want to add a parameter. There we go. And now all call sites are breaking because I added a parameter. I would have thought that writer would help me a bit here, but we can do a step in between. We can make the parameter, give it a default value like this. So now everything compiles. I don't really like default values, so I'm going to change this signature. And I'm going to say it's not optional, it's required, and just give it like a default value on all the call sites, which is interestingly exactly what we need. We don't care about the amount of food and all the others. So tests are compiling. Let's see if the tests are running green. Of course not, because we don't have a Pekingese subtype. As you can see, it's throwing it on the parameter, on the type parameter. So we can now implement our Pekingese. And we're gonna just implement a new arm, Pekingese, which is a new kind of dog. And that only is interested in the amount of food. There we go. So this should all work. Implement missing members, which are running speed and bark. Now I'm taking big steps again, but I have faith in myself. So running speed is just the default running speed, and bark should be hungry. So this should compile and actually be green. I'm calling my shots here, so I hope it's correct. Yeah. So that's the first unit test down. Let's now test the boundary, like exactly 100 bits of food. And that's a test. Let's rename it just enough, this case. And if it has 100 pieces of food, it should be satisfied. It should say something different. So let's see this test fail. We're at the red step of our red-green refactor. And it's red. Now let's implement the fix. I want a read-only field, and I want to check this field in this bark. If it's less than or equal than 100, it's hungry, and otherwise it's satisfied. There we go. Oh. 100 should be enough, right? So 100 should be enough. Okay, so it has to be smaller then. I think my example tests I wrote down a bit earlier say that 100 should be enough. Yeah, no, 100 should be enough. 101 should be enough. 99 is a problem. So yeah, tests are green. Let's maybe add one more. So we're sure. With enough food, it should also say om nom. But you get the idea. We add some tests until we are satisfied. We add tests until we think we are done, until fear turns into boredom. And I am getting bored. So I think we'll end the session here. And if we take a look at implementing the easy change after we refactored, it's just introducing a new subtype and growing our factory method. So yeah, that all looks great. And if we look at the time, we are clocking in at about 14 minutes. I am very happy with the code because I had rolled it. So I think time 14 minutes, code quality, excellent, fun. I like programming, so I had fun. This is the baseline. Let's now take a look at how AI augmented coding works. All right, folks, this is it. This is the reason why you clicked on this link. We are going to be programming with the help of AI. So we are going to do the exact same experiment that we did just a second ago, but this time we will be using an AI-assisted coding tool. So let me drop right into the code. And before we put on the timer and we start racing towards the finish, let me first showcase a bit what these typical AI-assisted coding tools provide for you. I installed claude-code. I have my preferences for the IDE you're seeing here, Writer. And I love my tools to get out of the way of my work. So I don't like those VS Code forks like Cursor and stuff. But if you like them and you use code, you do you. Tools don't really matter at this point. And I can promise you next week, a different tool will have taken over the internet by storm. So don't get bogged down on choosing the best tool. Anyway, what does claude-code look like in my IDE? Let's press that button there, and nothing much happens. This is the only thing that changed. Welcome to claude-code in my command prompt, and I have this little prompt box right here. Now, if you have been using ChatGPT, you know what this thing is. I type some text. The model does some random, some black magic, not random, does some black magic, and out comes a response, right? Well, no. That's where it starts, but this does so much more. This has some like thin library around that thing, and that library gives you developer superpowers. What does that library do for you? Among other things, it allows your LLM to actually look at your code, find files, find text in files, update files so it can change the code without you having to copy paste stuff like that. It can also integrate with whatever tool you have running on your machine or whatever tool that is running on the internet, which is stupid powerful, also stupid unsafe if you don't if you don't like pay attention to what integrations you mix. But again, topic for another day, topic for tomorrow. So it can do a whole lot more than just prompting text and reading responses. And we're going to show that now. So let me slowly start the timer so we can run the experiment. It is running. So how would I typically start my work as a dog API developer? When I did it manually, you saw me refactoring first. And then when we were ready to add the Pekingese behavior, I did test-driven development. So I wrote one single test, then I implemented the code for that test, and then I cleaned up after myself, or I refactored. And only then did I add a second unit test, and the whole cycle repeated. So it's test, code, clean up, test, code, clean up. When I'm working with LLMs, I typically don't do that. I typically provide more tests up front. Why? Because LLMs love context. They don't like too much context, then they get confused. But if you can provide, when you're implementing a new user story, for example, if you can provide a full near complete set of unit tests, or a table containing the tests, and then convert them to unit tests, whatever, that tends to have better results for me. So as you can see, I added all the unit tests you saw before when we did it manually already to my code base. It's not compiling. This Pekingese thing does not exist. This method or this constructor has less arguments than I'm using here. So this code does not compile. But now let's ask AI to just implement it based on these unit tests. And this is the second, next to my tests, the second big difference to programming, where I hit the keyboard a whole lot. When you are working with LLMs, it kind of starts to make sense to type less, talk more. Even if your dictation app is not perfect and there's typos and misunderstandings, these LLMs are great at glossing over typos. So I'm just going to use a speech-to-text app to prompt the model, and then I'll get flying. So let me prompt the model. Okay, Claude, today we are going to implement a new kind of dog breed in this code base. I already added the unit tests in the dog tests file. We're going to implement behavior for a Pekingese dog, by the way. So please take a look at those tests and implement the logic. There we go, and we fire off the prompt. And it takes a couple of seconds. And a first interesting thing you'll see is it's gonna read the file. So I didn't have to copy paste anything. It's just looking for the file. Now it's reading it. It's looking for the dog class right now. So it's looking in the code base. Where is this dog type defined? And this takes a couple of seconds. This kind of feels slow when you're in your development loop, but it's fast enough, I've found. It's even hit diffing. I don't really know what it's trying to do. Oh, it's trying to find a difference between the old version of the unit tests and the new one, probably, so it knows which unit tests are new. That's kind of smart. So it understands the current implementation. This is another big difference. It's generating a plan, or sometimes you have to nudge it to generate a plan, but it's taking like a structured approach. And more important than that, at any time I can press escape, shut it down, and ask it to revise its plan. So before it goes gun-ho vibe coding off into the wilds, you can actually steer it in the correct direction. And now it's proposing some changes. And usually you get this in a nicer view, like you see here before, with a left and a right pane before and after. But I had some trouble setting up the plugin for the technologist among you. WSL and Writer, and then a Claude plugin is a horrendous combination. But I digress. So it shows you in a clean view, familiar to developers, what the changes to the code are that it's proposing. And if I now take a look at this, I see, okay, yeah, it's taking into account the new variable, the amount of food, and it's implementing the Pekingese, and it's calculating the running speed and stuff, and it's barking. So that all looks correct. But if you remember our manual baseline experiment, I did some refactoring. I cleaned up this code. And right now, it's not suggesting to clean up anything. It's just gonna plump in more code. Which maybe might be fine for your use case, but if you're developing a big product, working with a lot of people, a lot of AI, it needs clean code as well. You might want to spend some attention to the design. So we're going to ask it to first refactor and then do the changes. You could, in theory, have it hammer out the code as it's proposing right now and then start a refactoring session, but I'm going to choose arbitrarily to mimic my manual flow and first make it refactor. So it can easily implement the dog type. So I'm going to say no, we're not doing this. And I'm going to tweak the prompt a bit. I'm going to provide a follow-up prompt. I don't like just adding to the current code. I would like to refactor first. Would you please use the refactor conditional to polymorphism refactoring? Would you please use that one to make the class more open-closed and then implement a new Pekingese type? So it goes off thinking. What I said is like a lot of mumbo jumbo, but if you are a software engineer with any kind of reading interest, or if you took some classes, you will have heard about Refactoring, the book by Martin Fowler. And replace conditional with polymorphism is literally a refactoring in the book. So I'm not inventing new words here. I am using technologist lingo. So again, it's saying, okay, I'm going to create a new file called dog behavior and some abstract methods. So it's kind of going to do the same thing I'm going to do. And I would just accept this, but I have like my solution in my head. So I'm going to say no, please don't introduce a new abstraction called dog behavior. Please do this in the original dog class. Don't invent a new dog behavior abstraction. Please just evolve the current dog class and implement subtypes for that. So one big difference you see already with the manual refactoring flow is I am doing the same things, but I am not doing like these micro refactoring steps. I am lifting the conversation up to a whole new level. I am talking like I would talk to a pair programming partner with a lot of experience. So let's take a look at the to-dos. It's going to say I'm going to make dog abstract, create some methods, and then create all those subclasses, update the unit tests to use the concrete subclasses. No, I don't want it doing that. I want a factory method just as we had. Please introduce a factory method instead of directly instantiating the subclasses. Pro tip, we will need to be working from home when we are working with these tools because we'll be talking nonstop. Return to office, yeah. I don't want to work in a cubicle. I don't want to work solely with AI either. I want to see people. But okay, digressing again. The broader impact of these tools on our profession, that's for a later video. Right now, I just want to show you what it looks like. So, okay, we're getting another result. Sure. There's the constructors become protected. I see a factory method. That all looks great. I don't like the optional value, but I'll allow it. And one thing we did in our manual experiment was push down all those methods to the subtypes. It has not done that, and that's the final tweak I'm going to make, and then we're going to fire it off. That looks good, but please push down all properties and methods in the dog class to the subtypes if it makes sense. If they are shared between subtypes, keep it in the dog class, but otherwise push them down. There we go. I think that's the third or fourth iteration on our prompt, but the plan is becoming solid. That's, again, a big difference. There's not a single line of code has been changed for now. It's all just thinking, planning, building up context. Okay, so now the iterations are becoming faster, clearly. So we're converging, hopefully. And it appears like it pushed down things. For example, here, it pushed down things. The retriever only has number of bones. So yeah, I am happy with what I'm seeing. So I'm going to say, make this change and don't ask me again. So now we're going to put on turbo mode, YOLO mode. Now it'll just start changing code without any intervention. And that goes pretty quickly, as you can see. So it's a whole lot of upfront planning and preparation. And when the actual programming happens, that's mere seconds. There's a build error. So notice that it's building the code, running the unit tests. That's pretty impressive. Because I'm not pressing any buttons here. I'm just looking at prompts, drinking my coffee, talking with you. So it's a bit of a different experience. This is actually an interesting point. It's saying, oh, I only changed like the unit test file and the dog file. And now you ask me to run the tests and compile. And now it's not compiling because that dog type is being used in this legacy code base all over the place. It's not a legacy code base, but it's big code base. That's my point. So this is something that those IDEs and those refactoring tools have figured out already, and they do this up front. LLMs even if you nudge them to do it, to like search for references, they have like the tendency to only look at what they know. But with the addition of them being able to compile and test the code or run the test automatically and verify that they are green, they can figure out that stuff is missing. They can look at the build output and see that, oh, this thing is being used somewhere else in my code, and it can start correcting all the parts of the code without human intervention again. That's when I saw this, I understood that we are at an inflection point in our profession. This is becoming impossible to ignore. We have to start experimenting with these things, which is why I'm making this video, of course. We are 12 minutes in, so if you were hoping that AI-assisted coding tools would give you a 10x improvement, I am sorry. Okay, the build is still failing. You can take a look at the failure, and if it takes too long, I tend to manually intervene and start fixing it myself if it's something small. But for the sake of this demo, I'm gonna let it churn on. Actually, that's a pretty relevant point. If you see that it's thrashing or doom looping on something, and it's like a one-line fix, you see it, please do not reprompt, please just fix it. we are trying to save the planet, and prompting for every little detail will not be the most economically the optimal route. So now it ran the tests. Add Pekingese to doc type anim. I don't know why that plan is formulated in that order, because that sounds wrong, but let's take a look at the outputs. Now it's building the code. So that's something I added to the system prompt, like always make sure when you return control over to me that the solution builds, so I don't lose time. And this thing you see here is, oh no, sorry. So yeah, the build also always takes a couple of seconds, so this is not surprising. Let's see what it's actually doing. Okay, build succeeded, 30 seconds, great. Excellent. Let me complete the final to-do. And then I have it play a beep so that when I am not looking at my screen or when I'm doing something else, the IDE beeps and I say, okay, it's done. So let's take a quick look at what changed, shall we? So as you can see, all the code has been updated, all the call sites for doc, the doc type. Let's take a look at that quickly. That looks almost exactly like how I would have implemented. So that's pretty impressive. I am sorry. So yeah, I am very happy with this code. I would commit this and send it home. And that's what programming with AI looks like. So now let's go to some conclusions. All right, time for some conclusions. Where to start? If you don't care about software design as much or having it your way, this tool will significantly improve your productivity. If you care about design and you want to have it like a specific way, you either need a big code base where this model can base its programming style on, or you have to be very hands-on, as you could see me doing. But this thing is shaving off hours work per week for me. It's not a 10x improvement, so this is not the 10x developer generator, but it's significantly improving my productivity. The way you have to work is different, but you have to know exactly the same things as I did before. I have to know all the refactorings. I have to know what good design looks like. I have to know what a good development process looks like, how you do test-driven development, stuff like that. And there are some slight changes, or not so slight. There's a different way of looking at the programming, but the big fundamental principles, they are the same. So what is my point here? Yes, improvement, productivity improvement. Yes, you still need to learn programming. And also my biggest point for today is, this thing has crossed the chasm. This thing has jumped from being a fun little gadget to actually being useful for even software professionals, even software developers. So if you have been a skeptic like me, if you have been putting your head in the sand, it is time. Let me repeat that. It is time to start taking these tools seriously. I think a couple of months, years from now, we still will have developers, but those engineers will be using these tools. And if you are not using these tools, you are going to lose a competitive advantage here. It's time to wake up, people. It's time to look at these tools. Now, I'm doing a lot more with these tools than I showed you just now, and I'm going to provide some examples of how I use them and how you could use them yourself in the future. I'm also going to be talking a lot about the impact of the industry and the impact of me personally, but I'm going to save that for later. This was just a showcase of what it is and what it feels and looks like to program with AI-assisted coding tools. So yeah. The world is changing, and I've been never more like dubiously excited and terrified at the same time. Terrified not for my job, but for the environment. But I'm also very excited because the playing field has just reset, and there are no best practices, no best way of doing things. We're all just experimenting and playing along. So please start experimenting and please start playing along. See you next time. Bye-bye.